Hello, and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Before we get started, I just want to say thank you to my employer, Equinix Metal. They provide the time and the resources for me to invest in producing this show and making sure we all have great cloud-native content to learn together. If you want to check out Equinix Metal, there is a code, rawkode-live, which you can use at metal.equinix.com. Check it out, have some fun. Today, we're going to take a look at the Keptn project, and I have a great guest, Jürgen Etzlstorfer, who is an engineer at Dynatrace and a maintainer of the Keptn project. Hello, Jürgen. How are you?
Hi, David. Hi, everyone. Thanks. I'm good. How are you?
Yeah, I'm very well, thank you. I'm looking forward to today's session and learning how I can use this really cool project in my Kubernetes delivery pipeline. I think the best way to get started was, why don't you take just 30 seconds or a minute, or in fact, take as long as you want, but tell us a little bit about you, about the project, and then we'll move on from there.
Okay, cool. So my name's Jürgen. I work for a company called Dynatrace, and we started, or my role at Dynatrace, maybe I start from there, is officially a technology strategist. I joined the company about 3 years ago, and I have been member of the Dynatrace Innovation Lab since then. And a couple of years, maybe it was around 2 years ago, we started this project. It was not called Keptn by then, but we found that we have a lot of best practices that we are using when it comes to cloud native technologies, when it comes to delivery, when it comes to quality of software that we are already using, and we try to basically provide everything also to other organizations and also to our customers. And this was the basic idea. Let's start an open source project and let's make everything that we already know, let's make it available for others, and let's make this let's make this a platform that everyone can use. With this project, or with this idea, the Keptn project was born, and it's now a CNCF sandbox project, and we are pretty excited to have it. And I'm also pretty excited to show it, or to take a look at it today with you.
Awesome, nice. So I believe you've got a few slides you want to run us through first, give us a little bit of a flavor, and then we're going to get hands-on and kick the tires on this. So let's pop that up. There we go.
Cool. Okay, so let me just introduce briefly the Keptn project, which use cases it solves, or it targets, and which problem it solves. If you want to take a look, there it's keptn.sh. We in Austria, or in German-speaking countries, we say Keptn, like the captain of a ship. That was the main idea behind it, the Keptn ships applications. So we will hear a couple of these nautical terms like a ship and the shipyard, and we will hear it anyway in the rest of the show. We also have Twitter. So. What is it actually, and what does it do? So we came up with this figure here. We actually target a couple of different use cases, from progressive delivery to quality gates as one part of progressive delivery that you can use maybe in other delivery frameworks that you might already have in your organizations, and where you don't want to use maybe Keptn, to auto remediation when it comes to operating your microservice applications. This spans our use cases, and everything is built on a GitOps approach, where you just bring your configuration files, and Keptn will manage these configuration files and will also connect to your tools. So David already mentioned it's a control plane, a cloud-native control plane for continuous delivery and automated operations, and it's basically solving the problem of application lifecycle orchestration and management. So if you have Helm charts, and if you use Helm for deployment, you can do this with Keptn as well. So Keptn can use your Helm charts and deploy your microservices for you. You can also connect it to Argo. You can connect it to Jenkins. We have other integrations for monitoring tools like Prometheus, where you can use this data for your quality checks. You can connect it to JMeter for load generation and performance testing. You can connect it to Litmus Chaos for chaos engineering. So you can connect it to a lot of different tools. Everything is event-based, and with this, we are very open to broaden this ecosystem and to open up for tool integrations. And Keptn really brings together the different tools that you already have in your tool belt, let's say, and manages continuous or progressive delivery and automated operations for you. So how is, why did we actually start? I said this in the beginning briefly, because we saw that a lot of different organizations that we are working with, that we have heard from, they are doing a lot of manual tasks when it comes to delivery of applications and new releases. And these manual tasks are either in evaluating test performances, evaluating if the new build is actually better or if the new release is actually better than the last one, and also writing a lot of those pipelines. And these pipelines, they have grown pretty large, and this is one issue that we are also solving with Keptn. There is no pipeline code anymore. Everything is event-based, and you just connect your different tools, and you have very, very small configuration files that are for a very specific purpose. And with this, it's very easy to change them, update them, maintain them. And one part is also a lot of organizations, they spend a lot of time in remediating the issues. They might already have some playbooks in place, like let's say Ansible playbooks, or some, it can be shell scripts that just remediate an issue, but anyway, they have to be executed. And here we also bridge this gap by, from a, let's say, Prometheus alert, we can trigger a Ansible playbook or execute shell scripts or Python scripts that already remediate or try to remediate the issues. So we are, with this event-based methodology, let's say, we can bridge these gaps. So the first use case, yeah, thanks. The first use case where I think Keptn already brings some value is when you start to manage your applications with Keptn, because Keptn can already configure your monitoring. Let's say your Prometheus, create the scrape jobs, create alerting rules in the alert manager, create dashboards in Grafana. We have not even yet deployed the application, but when we onboard the application, that's also how we call it. It's a Keptn onboarding. It's we have a lot of these terms. But when you onboard an application and you are using Keptn CLI, that you can already use it to configure your monitoring solutions, set up alerts, create dashboards, set up scrape jobs, these kind of things. And as said, we have not even yet started to deploy the applications. Yeah, I think we'll see this later on, so I'll just skip this one. And the second part, where it's really we are bringing really a big benefit, is we have based our delivery pipelines on SRE concepts, SLIs and SLOs. SLOs is short for a service level objective, and the user of Keptn just defines a service level objective that can be based on response time, can be based on the error rate, CPU consumption, whatever. Everything that's queryable, or that's a metric, let's say, and you can query this from, for example, from Prometheus. You can define some service level objectives, and Keptn will set up a multi-stage delivery pipeline for you. And between each stage, Keptn makes sure that it evaluates the quality of your microservice based on the service level objective that you have defined. And you just define it in a YAML file, and the deployment and the triggering of the tests and then the evaluation, this is taken care of by Keptn. So for example, here we have the shipyard file, the SLO file, the Helm chart for deployment, and we can see that the shipyard file, actually that's the complete shipyard file for a multi-stage pipeline. We have dev, staging, production with a quality gate. That's basically the whole quality gate. That's the SLO file, and you will get this automated quality gate evaluations for each deployment that you're triggering with Keptn, and the data is then gathered in this example from Prometheus, and the tests have been executed by JMeter, for example. And in the yeah, this is how it works in a little bit more detail. We have these SLO files and SLI files. These are, you can think of this as a library of indicators and how you can fetch this data with a PromQL query, where you can you define your PromQL, and this is then executed when Keptn evaluates the quality gate. And you can just reuse, let's say, the error rate here. We just reuse the error rate in the objective file, and we specify the error rate has to stay lower or equal than 1%. And the time frame for the evaluation, that's actually calculated by Keptn, since Keptn can also trigger the tests. And Keptn will trigger the tests, let's say JMeter tests or Neoload tests or BlazeMeter, or whatever you're using. And once the tests are finished, Keptn will be informed the tests are finished, and it can evaluate for this exact time frame of the tests. We can evaluate the error rate, response time, number of database calls, and from this file, it will generate the total score. Start the evaluation, it will generate the total score by evaluating this, and based on the total score, it can then decide if it should be promoted to the next stage or if it should be rolled back, for example, to the previous version if you have a blue-green deployment. Okay. And for the third major use case of Keptn, this is where we automate part of your operations. We call it by closed loop remediation. And with closed loop remediation, what we really mean is that we are constantly evaluating if the remediation is actually, if it was successful. So we've seen that organizations, and also this is where we started also a couple of years, once there is a problem or an alert coming in, this can also be sent to Keptn as a cloud event. Keptn can execute remediation actions, trigger other tools, let's say toggling a feature flag or triggering the rollback of a deployment or executing some Ansible Tower playbooks. So Keptn will trigger, let's say, an Ansible Tower playbook. Once it's finished, Keptn will evaluate if this action of Ansible Tower did actually resolve the issue by re-evaluating the quality gates, reusing the SLO file that you already have defined. And if it's remediated, job is basically done, and the alert can be resolved, or the problem can be resolved. And if it's not remediated, Keptn can take the next action, and it can be a sequence of actions that can be taken. And all these actions, they are actually evaluated if they remediate the issue or not. So, for example, we have one demo application where we send an alert via the Prometheus alert manager, and in the remediation file, we define two different remediations for one specific problem, and the problem in this case is a response time degradation. That's the name of the problem. This will map to the alert of Prometheus. So these two, they basically have to be, they will match, and we will then have a number of actions. So in this case, two actions. The first one will be executed. It's scaling. Scaling is a built-in functionality of Keptn, so it can basically change the values of the Helm chart. The replica set values of the Helm chart will increase it, in this case by +1, or you can say by +10%, or whatever might be the right action. We'll then re-evaluate the SLO file. We'll do this evaluation of the quality gate. If it's remediated, everything's fine. If not, it will go to the next action. This is, in this case, it's the toggling of a feature flag. So in this case, we actually want to disable a campaign of a specific campaign ID. We can think of this like a promotional campaign that has been initiated. Maybe that's generating a lot of problems for our response time. Maybe it's it has to do too much, I don't know, database calls, for example. So this can be also triggered. We don't define the tooling in these files. The tooling will be just listening for these events. So if you want to move from one feature flagging framework to another, you can still use the same remediation files, because what you will do is you will just change the part which listens for events from Keptn. And in this case, might be resolved or not. We can then escalate it. We can send all these, everything that's going on, all these cloud events also to Slack, for example, or just sending it to Slack when it escalates and we could not resolve it. yeah, that's the main or the major three use cases. And as said in the beginning, Keptn is built as an event-based control plane that lives in your Kubernetes cluster, and you can send cloud events to this control plane, and the control plane can also send cloud events. So it receives and sends cloud events, and this is how the tool integrations are actually done. We already have a couple of tool integrations, and we see more and more, or we see this growing as more and more organizations are contributing. For example, we received a contribution for a Slack bot where you can control continuous delivery workflows with a Slack bot. So you get the whole evaluation of the quality gate directly into Slack, and you can just accept or reject if this build should move on to, let's say, from your dev environment to pre-prod, or even from pre-prod to prod. So that's pretty cool. We have a couple of integrations here in our contributed to the Keptn ecosystem. Yeah, that's our latest integrations, I would say. And yeah, maybe from this, we already take it from there and take a look at Keptn. If you want to also afterwards maybe take a look at Keptn's keptn.sh, that's our main website. And yeah, I think we're good to go.
Okay, so it does a lot. there's a lot of things here, right? So I mean, I'm very excited now. I have a couple of questions, but before we get to them, we got one from the chat. So Aaron has asked, is it possible to use Keptn outside of Kubernetes?
Yes. So when I read this question, I can definitely answer with yes. Keptn, the applications that are managed by Keptn, they don't have to run in Kubernetes. But Keptn itself is built to run in Kubernetes. But we've also built a Keptn on K3s, a very, very small Kubernetes single binary distribution that you can just run on your small EC2 instance, and you just install Keptn on K3s there, and then it acts, the control plane acts on this EC2 instance, and you can send the cloud events to Keptn. It's just built as a couple of microservices, and they need some kind of orchestration, and we decided to go for Kubernetes. But yes, you can also use Keptn for traditional applications. I would assume, or I would just argue, it works best with microservice architectures. But we also see monolithic applications being quality gated by Keptn.
All right, nice. So on your slide, in fact, let me just pull that back up. Can you go back? Was it one slide, two slides, maybe? This one, okay. Mm-hmm. So if I'm trying to think, and we'll get hands-on in just a moment, and I'm sure all my questions will be answered there, but I'll throw them out anyway. It's like Keptn runs as a control plane to monitor pretty much everything after I get merged into my main branch to my application running in production. Now, you talk about environments and how it can handle progressive delivery across those environments. Now, the example here is namespaces. Could those be separate Kubernetes clusters, one for dev, staging, and production?
Yes, but only in the next version of Keptn. So we are working on this. So today we have to use Keptn 0.7.3. That's the latest version, and we're working on 0.8. And with .8, it will be possible to have to manage different clusters even in different clouds. So then it doesn't really matter where the cluster lives. But right now the control plane can manage one cluster, and we are doing the separation between the control plane and the execution plane, and then it will be easier.
All right, sweet. Okay, let's get started then. So if I pull up my screen, there we go. We have the Keptn website. People can check that out at keptn.sh, and there's documentation, tutorials, etc. The tutorials, I believe, is what we're going to get started with today. So these are just guides that anyone can follow along in their own time. Click start, and then you just guide it through step by step, right? So are we doing the Keptn full tour? That sounds exciting, on Prometheus one, right? That's the one we're going to check out.
Yeah. That sounds good. And the other ones, they are basically for different use cases. They show you, for example, Keptn in the box will use micro Kubernetes. We also have the guide for the Keptn installation on K3s if you want to do that, to connect it to Argo CD. So we decided to go for tutorials. We also have a documentation, but tutorials are more guiding you how to follow the concepts of Keptn and how to use them to the best.
So here's the branch I want then for my multi-cluster approach. Okay.
Exactly.
We won't do that today. I won't put pressure on you. So we get this kind of, all right, here we go. We got step-by-step guiding us through the full tour. So when it says the full tour of Keptn, that's just going through all of the components that you kind of listed on those slides, right?
Exactly. That will explain how to install it. Will explain how to do delivery with Keptn, quality gates with Keptn, and automated operations, or let's call it self-healing with Keptn. And we'll bring also all the tools that you will need. So in this case, yeah, we'll ask you to install Istio because that's what we are using for the route generation and the traffic shifting between the blue-green versions. So this is why we need Istio in this case.
All right. So as this is recommending that I run Istio 1.5. I'll just check what I actually have. 8. So should I install this version? Does the version matter?
I have not tried with the latest versions. We just had that the previous versions did not work pretty well, so we just decided to go for this version. This is the most stable version in for our demos here.
All right, that's fine. Why did that not work? Oh, because I put the path after. Let's just do this. Much better. Okay, so we have Istio control 1.6.5, and we're just going to run an install against our cluster. Default profile, the correct one, yeah?
The default, yes, that's cool.
Istio is one of those things that I've been putting off for so long to play with that I really am going to have to start experimenting with it eventually.
Actually, when you're using Keptn, you won't see a lot of Istio because Keptn is generating the virtual services and all the traffic routes that you will need for Istio, the ingress, these kind of things. So we won't see a lot of Istio. It's just used behind the scenes. But it's definitely a very, very interesting project.
Is that something that Keptn could, more have a dependency on the service mesh interface rather than Istio, or is there stuff in Istio specifically that's needed for Keptn to work beyond the service mesh interface?
So if we are not doing continuous delivery with Keptn, if we are using, let's say, Argo CD for continuous delivery, and we are just using Keptn for the quality gate part and the automated remediation part, then we won't need Istio. It's when we are going for the full installation of Keptn and we want to do continuous delivery, we need Istio. We were thinking about also moving to the service mesh interface, then also supporting Linkerd and other service meshes. But it's just it was never the right time to broaden up for this because what we see is that more reusing already existing CD tools like Argo CD, Argo rollouts, Spinnaker, and trying to integrate with them and actually providing integration with them seems like the better approach right now.
All right, makes sense. All right, so yeah, we got installation complete. We hit next, and I'm now curling for a Keptn CLI. There we go.
Okay, that was fast.
My connection is pretty good. Well, when it wants to be, of course. There are definitely days where it's not good, but today it's been pretty good. So we have the Keptn CLI. Nice. Okay.
That's pretty good. So yeah, and now with the Keptn CLI, we can install Keptn in our Kubernetes cluster. As said, for our installation type, we are going for this use case continuous delivery. If we don't decide for this use case, then it will be a smaller installation of Keptn without the services to do the full continuous delivery. But then we have to take care of doing continuous delivery by ourselves. So we just go for full installation here.
Okay. So you want me to change continuous delivery to full, or is continuous delivery the full installation?
That's so we just leave it like it is. Yeah.
All right. Okay.
That's the, let's say the full installation with the continuous delivery use case included, which just asks us if everything correct. Yeah.
I'm just going to keep clicking buttons when things are presented. If I do anything wrong, just feel free to yell at me. But so this is going to. Oh, so it's installing Keptn. So I could have done this via the Helm chart as well. I'm assuming the CLI is just a wrapper around that, provides some values for the use cases that are selected. Is that roughly right?
Yes, exactly. We had it differently, that we had a really a job that was really executing step by step the Keptn installation, but we thought it's best to move to Helm chart since it also provides possibility to install it via a Helm chart without the installer. That's what we also see. Sometimes it's not allowed to install any software with an installer script, but just with Helm charts so that organizations have full control and can take a look what is actually installed. In this case, it's basically applying the Helm chart. And we will see a couple of pods spinning up in the Keptn namespace. So we install everything in one namespace, and that's the Keptn namespace. If we want, we can try kubectl get pods -n Keptn. We will see what is actually creating here. Yeah, we'll see. That's basically the core of Keptn. A couple of different services that talk to each other.
Okay, so we've got Nginx as a gateway. We've got a bridge. I don't know what that is yet. We've got config, and we've got an event broker. Is that NATS, or are you using something else there for the event broker?
It's actually, yeah, it's NATS. So you can also see the Keptn Nets cluster that's deployed.
Oh, yeah.
Then the bridge is actually the Keptn's bridge is the, let's say, the control center of Keptn. That's our UI. We will see the UI later. The lighthouse is the one component that is responsible for reaching out to all these SLI providers and doing the evaluation. The shipyard is responsible for creating the environments.
Is Gatekeeper open policy agent or something
no,
else? Oh.
It's our own internal gatekeeper. It's the one component that decides if one version of a microservice is allowed to move on to the next stage or not. It's doing this decision making.
Right. I'm not seeing any puns here for walking the plank, so I think we need a new service for that, for maybe evicting other apps. All right. I like the nautical theme. It's always amusing. Okay, so let's see what's next. So we have to configure Istio and Keptn. I guess I just trust this and run it.
You can, yeah. It's actually, this one is just downloading, and the next one is then we will just run in the next command. So we can also take a look here. It's what it's doing is it will create the ingress, and it will create also a gateway, and it will restart our restart one service of Keptn that it can fetch this configuration.
All right. Okay. So we're just going to run it. Parameters? Nope. Okay, good. All right, let's give that a second. All right, and then it tells you what it's doing anyway. Right, cool. Got it. And now we need to configure our CLI to speak to the control plane.
Exactly.
And I can verify this.
Okay, so we already see where your Kubernetes cluster lives. So we can take a look at the API endpoint, and there is also the bridge that will be exposed here. I will just warn you. So whenever we are doing that's the API of Keptn. It can be controlled via the CLI or via the API. And you can imagine that when Citrix built the integration with the Slack bot, they were more using the API. Today, we will be more using the CLI since it's easier instead of writing all these cloud events and then sending them to the API.
Yeah.
So with this, we already installed Keptn. We have access to the Keptn API, so we know it's up and running. And we could also already take a look at the Keptn's bridge, but it will be empty anyway. So we can go ahead and create our first project, onboard our first services, and then take a look at the bridge.
Okay, so we're going to clone. Okay, so it's just an example repository. And then we're going to take a look at onboarding carts. I should just pop open. Okay, nice. So wait. So I still have to create the project. Okay, I've just cloned it and opened it, but it's still
yes.
Okay.
And here we can go, if you want, we can link it to a public Git repository in GitHub or GitLab or wherever you might want to run it. So we can also take a look at all the different projects and all the on everything that has been created by Keptn, or we can just assume that everything's fine and we just trust that the Keptn repository that is managed by Keptn in the cluster will be fine. So we can go with the Git upstream, or we can also link it afterwards. So right now we can also go with the installation without the Git upstream, and we can do the link upstream, the Git upstream afterwards if we want. So that's open to you.
All right. So let's see. So I could just create an empty repository and then fill in those variables. Is that?
Yeah. So you can even create an empty organization and you can have it there. So afterwards you can delete the whole organization if you want. They're also for free organizations.
Okay. So let's call this Rawkode Keptn. My own email address. All right. Skip. Okay, so I have an organization. There we go.
Yes, and we just need one project in this organization.
Nope. Yep. Let's do that.
Since we are going to onboard, let's call it Sock Shop, since we're going to onboard a shopping cart. I think for Keptn, please make it Sock Shop without the dash, because in previous versions we had issues with the dash, and just to make sure everything's fine here. Yeah.
There we go. Okay, so down here, what we need is just to expose these. Okay, so let me just modify them here. So is this my organization or my actual username?
That's your actual username. Then,
okay.
Yeah, we would need the... or you can just copy the... can you... I'm not sure if it would work in this way. Maybe we just need the URL that is given by GitHub. Oh, it's exactly this. Okay, sorry. Then is it? Okay. I always go for the HTTPS version, so this is why I'm confused.
All right.
All right. Yeah, maybe we can go for the HTTPS version. I think that is actually the one that we want.
I actually need a get token.
Yeah, and we might need this token, but I'm not sure if we can share it here on the screen, or you would go for a different display or monitor where you're going to set this.
Yeah, I'm just getting one over here. So let me get token, personal access. Any specific permissions it needs?
Read write project will be just fine. So I think that's the first two permissions.
Okay. Let's see what happens then. What's that? Done. So what I'm going to do is just move this over here. And that. Handling secrets on this stream is always the fun bit. Okay, so I can pull this back and pull my terminal back.
Yeah, I should have warned you earlier, but I totally forgot.
Oh yes, I need to export that variable. So get token. Right. See what happens. And the documentation just wants me to run this command here. Which didn't copy. All right, so we get. So what's going on here? Do you want to fill this in a little bit?
So what Keptn will do is here, it will start to create the project and it will create different stages. And these stages, they will be managed by branch. So it is going to create the project sock shop. That also means the folder in the Git repository, creating the branches in the Git repository, and it should already be synced to your Git upstream. So it's always doing this, that it will sync it to your Git upstream. So if you reload it here, we can already see the shipyard file, and you will also see 3 different branches for dev, staging, and production. So with this, we have already created a, let's say, the environment of a multi-stage pipeline, dev, staging, production. And if we can take a look in the shipyard file, we will see how this is configured. So in our dev stage, we do have a deployment strategy which is direct, so no blue-green deployments for our dev stage. We just deploy directly into the dev stage, and we execute some functional tests. That is the instruction how this stage should be set up, and is set up by Keptn. For staging, we have a deployment strategy which is a blue-green on the service level, and the test strategy is performance tests. So the test integrations, they get the let's say instructions to execute performance tests, and an approval strategy is set to automatic for everything. That means either, or it doesn't really matter if the quality gate gives us a warning or a full pass, we promote it automatically into this stage. For production, the approval strategy is a little bit different. If it's a full pass, we deploy it automatically into production. If we get a warning, we would have to click on or approve it manually, either by clicking in the Keptn's bridge or doing this with the Slack bot or with an API call. Just approving this, you can have an integration with other tools as well. And we also have a remediation strategy for production. So that means if there's any issue, any alert sent from, let's say, the Prometheus alert manager in production, Keptn will trigger a remediation. For other stages, Keptn won't trigger a remediation. This is basically everything that we have defined in this, and this is how Keptn will behave in these different stages.
All right, that makes sense. Okay, so we have a question as well, which we can tackle just now before we move on. Bala is asking, does Keptn expose any metrics that can be consumed?
The Keptn directly does not right now expose its own metrics, of the performance of Keptn, if this is the questions. Keptn can collect different metrics from SLI providers, and which metrics, like a response time or a total amount of calls or whatever you can think of, these are just defined in the SLI file. So you would just map it between the name of the SLI and the PromQL query, for example, or if you're using other monitoring tools, the name of the SLI and, let's say, an API call, how to fetch this query.
Okay, thank you. So let me just make sure I understand what's happened right now. So we have this repository created. I mean, if I click on dev here, we just got some metadata. So nothing's really being deployed to our cluster yet, right?
Exactly. We just defined that there is a project sock shop, but we have not onboarded the microservices yet. We can think of, like, we have defined the whole application, that we have a container for this application, and a logical container, let's say. And now we will onboard services. So we could onboard a front end, a database, a back end. And what we will do is the demo application comes with 2 microservices. One is the database. It's not really a microservice, it's a database. And the other one is the microservice. And we will then do different deployments with this demo application.
Okay, let's jump back over to our tutorial. So we have, oh, that's alternatively. Okay, cool.
Yes. Okay, so if you don't want to have this Git upstream, if you just want to do it locally, then it's totally fine. It's also working.
Okay, so now we can take a look at the bridge.
This one will print a token for the bridge. Since it's just a demo environment, if you're fine with the token to be exposed on the stream, if you delete the installation afterwards, it's totally fine. But just
okay, yeah, that's fine. And then we're going to run to this. What's that doing? Let's see. Echo get ingress. All right. Okay. So this is going to print out a URL, which we can click on this. Oh, of course, it went to the wrong tab. I'll just copy that. There we go. And now I need our password here. So let's see. And go.
Yeah.
All right. So this is the user interface. I can select the application. I can see my 3 environments. Not much going on just yet. Services and okay, some integrations. Cool. Let's see what's next. Now we have to onboard our first service.
Exactly. And in the tutorial, we have 2 services that we want to onboard. The first one is the cart. It's actually the application of the shopping cart. And in step 2, what we also do directly here is that we add test instructions for our different stages. So for dev, we will add test instructions for Chemida, which is just a functional test, basically checking if the API is available of the cars microservice. And for the performance test, it runs a couple of thousand requests against the service. So this is everything that we can see here, is creating the application and onboarding actually the Helm chart. So this command will also upload the Helm chart that lives in the carts folder. We'll upload this to the Git repository.
Is that a typo? Carts?
No, that's actually correct. It's a little misleading because it's the carts. It's a shopping cart.
All right.
And it's a chart of the cart.
All right. So let's onboard that then. Let's pop over here after onboarding. Okay. Yeah. Let's run it. These. Give that a second.
And the cool thing here that you just have to define your Helm chart once, and then you basically pass it on to Keptn. And from this point, you don't have to touch the Helm chart. You can do most of the things with cloud events or with the Keptn CLI, and you don't have to maintain it. They will be managed in the Keptn Git repository, and depending on the stage. So what we have seen is for the staging and the production environment, we have defined a blue-green deployment. So there will be different manifests, Kubernetes manifests created for these different stages, because for blue-green, we need virtual services. For Istio, for direct deployments, we don't need this. We can go with the standard Kubernetes services. So this is just how it is done. Actually, it should return a little bit faster. Maybe that's the Git sync that it might take a while, but yeah, we'll see.
So should we see anything here? Oh yeah, it's had a push list a minute ago. Okay. So we can see that it's, yeah, it's added all the chart stuff. Okay. No, okay. It's getting there. Injecting Istio into the thing. My copy paste is a bit temperamental today. Let's just try again. So what does it mean by resource here?
It means it will upload the basic check.jmx. It's an instruction for a JMeter execution. And it will just add this resource to the JMeter folder for the service carts, so for the shopping cart in our dev stage. And for staging, you've also just uploaded a file. So if you go, for example, in dev, we will see in carts 2 folders, one for Helm and one for JMeter already. And here we just have the instructions which JMeter tests to execute. JMeter is one service that is, when you install Keptn with the continuous delivery use case, JMeter is installed with Keptn by default. You can, of course, remove it afterwards, but it's just one of those what we call battery included services, since we see it's widely adopted that organizations have JMeter files and use JMeter for their performance and load tests. And so with this, you can just add the JMeter file, and the JMeter service will then pick up those files and will execute them. We'll see this just in a second.
So, if I wanted to, could I omit the Keptn add resource command and just get add and push myself? Would that still work, or is there going to be something missing from that?
You could actually, you can also do it with the git add and git push. That works, since Keptn always first takes a look at the remote branch, syncs it to its internal Git repository, and then executes. So whenever there's new changes on the remote branch, Keptn will pick them up.
Okay, so now we're going to onboard our database, right?
Exactly. And for this, we can also see it here as the last parameter in this line, that we are overriding here the deployment strategy. So we have defined the deployment strategy on the level of the project. We defined for it's in dev, it's direct, in staging, it's blue-green, and in production, it's also blue-green. For the database, we don't do blue-green deployments in this case, so we just go for a direct deployment for the database. We won't do a lot of deployments with the database anyway, so it doesn't really matter.
All right. Well, that finishes. Let's just tackle a couple of questions we've received. So Bala has asked, would Keptn be suitable for deploying on edge devices?
Yes. So it's, if you have your as said, right now Keptn is doing deployments on the same cluster where the Keptn control plane is also installed. So I would not go right now for edge devices here, but with the next version of Keptn, it's totally possible to do deployments also to other clusters or to edge devices. That's totally possible.
Okay. I mean, I guess you could have, like, depending on the edge setup, but if those edge edge devices were all part of a Kubernetes cluster, had a control plane centrally managed, I mean, Keptn could also just run there and still do deployment to those nodes, even though they're distributed, I would imagine. And you also mentioned that Keptn runs on KCS as a start of the stream, which I guess may be a good fit for those edge scenarios as well. Okay, one more question. Sam Pass is asking, is the Ingress running on the local host for the Keptn dashboard? Ingress is running on our cluster, our Kubernetes cluster, the same one as Keptn. I don't know. If you provide a few, I don't know how to answer that just now. I'm not sure if you do, Jürgen, but maybe Sampath, you could provide a few extra details there. Okay, we've onboarded our CarsDB, so now it's telling me, hey, go look at the UI. Let's do that. All right, and we can see we have 2 services. Not deployed yet, though.
Exactly. So it's everything that we have done until this point is basically a one-time setup. So we have created the project, we've onboarded our services, we've not yet deployed them, but they already know which tests they have to execute once we deploy them. They know if they should be deployed in a blue-green fashion, or if remediation should be executed for them. So we have already provided all these instructions, and in the next part, we now deploy the cards database and the cards microservice. So in the first part, we deploy the database. And here we can also see a little bit of the Keptn insights and details, because we call it Keptn send event new artifact. That's a very strong hint that Keptn is event-based. It's not an operator living in a Kubernetes cluster and doing things and looking for changes on the Git repository, but it's really event-based. So every time there is a new event, Keptn will act upon this event, and you send these events as a cloud event to the Keptn control plane.
So is this something I would use with Jenkins or GitHub Actions? Every time I have a successful build, I would maybe send a Keptn event there.
Exactly. That's exactly what people that are using Keptn are doing. Once you have a container image, then you trigger Keptn.
Okay, let's just get both of these going then. So we've told it that the CarsDB service has an image. So it's just going to pull it from the Docker Hub. So this is very synchronous right now with the Keptn send event. Is there a way I can just say send the event and don't give me any feedback? Like just, go and do it?
That's basically what you will be doing with the API. The API will just respond 200 if the cloud event is okay. This one is always opening up the WebSocket. You can also omit the WebSocket. It's I think it's -- no WebSocket or suppress WebSocket. If you go to the Keptn help, then you will find it.
Suppress WebSocket. Okay.
Yeah, suppress WebSocket. Yeah. So then it won't do the WebSocket communication, and it says unknown flag project.
No, this is a global flag. Let me move that.
Oh, yeah.
Oh. Did I copy it wrong?
No, I think it looks good. Maybe we can just put the suppress WebSocket at the very end. Maybe
is this a Cobra application?
Yeah.
It's always weird. Oh no, let's just remove it.
Oh, artifact is wrong. Artifact, it says here.
Always my fault. Always is my fault. There we go. Artifact. User error. Okay, and that was pretty quick. So I should set the event by suppressing the WebSocket. I'm saying just go do whatever you have to do in the background. So.
Exactly. But what you always get is the Keptn context ID. And with this Keptn context ID, you can always query the events that belong to this Keptn context. So in this case, Keptn will start the deployment. It will now do the deployment in the Kubernetes cluster. It will trigger the tests. It will do the evaluation after the tests have been finished, and it will decide if it should be promoted to the next stage or if it should stop. So everything is done now, starting from here. And in the Keptn's bridge, you can follow the sequence of events. And it will just, this demo application I think is a Spring Boot application. It's not tweaked, let's say, in any way, so it will just take a while to be deployed. Here we should already see actually the cards.db. Yes, so cards.db already says it's Mongo 422. And we also have the configuration for the first service. Yeah. It's not yet finished with deployment, but that's not the problem of Keptn, that it's slow with deployment. It's just that the demo application or this cards application just takes a while for to come up and for the first readiness probe to be finished.
Awesome. Okay, so Sampath has given us a little bit of extra detail on their question. So what they're saying is, when we ran Keptn configure bridge output, does that command create a public load balancer? I think I know the answer to this, so you can feel free to correct me if I'm wrong. But I don't think it does. I think it's just querying the IP addresses from the services inside the cluster. When we installed Istio, it deployed the Istio gateway, which then requested a load balancer from the provider. So that was all set up with Istio. There was no ingress set up, as far as I know, with that command. Is that right?
Yes. So the ingress was really part of the Istio part.
Yeah, it was. Cool. And the configure bridge, I think, was just getting us a URL that we can use. So,
exactly.
And if you're not familiar with the NIP.io, it's just a free service where you can put any IP address in their format, like you can see here. In fact, let me zoom in on that a little bit. Really cool when you don't want to have to deal with DNS records at all, and it just maps back to the IP address, which is part of the actual domain name. A really cool service. Okay, so let's see what's coming up next. This is 58 minutes remaining. There must be quite a lot in this tutorial.
Yeah, it is. But actually, it's just a wild guess of this 58 minutes. So we can always be a little bit faster. But let's see if it's already in Sockshop Dev. Cards is still
we have something pending. So let's just take a look at that and see if we've hit any sort of challenge. Insufficient CPU.
Okay.
Okay. So we've got 6 nodes. I mean, that should be all right.
I think that's just a problem that the demo application, we have not tweaked the resource request. So maybe it's just looking for a little bit too much.
All right, let's take a look at our resources. Okay, let's just, that's the limit, and then this is the request. Okay. If I modify that resource.
Yeah, actually, I think easiest is that we modify this in the public Git repository that we set up in the beginning.
Right. Okay, so if I come back
because
here,
that will be synced anyway, so we should be able to see this. But it will give us a hard time because the Helm chart. Okay, here comes the thing. The Helm chart is now, you have it in dev, in staging, and in production. So we would change it 3 times because Keptn is taking this Helm chart and putting it for each stage, replicating this Helm chart, so you can have it basically managed by each stage. So we can try to tweak it here a bit and go down with the...
I mean, we can just remove it, right? We can just say we don't really care.
Yeah.
Where's the save button? I know I should enter a better commit message, but oh well. So what happens when I do that? Does anything happen?
Right now, nothing happens because we have not yet sent an event to Keptn. Yeah, so we've just changed the deployment file, and what we should do is to send a new event to Keptn to do the deployment. So basically the same command that we had earlier, and we trigger a new deployment, and Keptn will fetch this. We'll fetch this again.
Let's give that a minute, I guess. And you're saying I should modify this in staging and production as well?
Yes, but can you take a look in the Helm repository? There is also there's a Helm and a Helm generate or a cards and a cards generated folder, and here we actually have to take a look in the cards generated, since the cards is the original one that we onboarded, and the cards generated is the one where we also have the Istio resources that have been created by Keptn.
I don't see anything.
And in the dev stage, or in the dev branch, in the staging, sorry, in the staging branch,
yep,
we should see them. No, nothing. Okay, then we have to take a look in the cards. Yeah, then maybe it's not in the generated. Then I'm totally wrong. So for dev, we already fixed it. That's fine. We have to take a look in the.
It doesn't seem to be doing anything. Okay, so let me try and understand what's going on here. Is there a way for me? Can I subscribe to the Keptn event? Can I see what events have been happening? How would I debug this situation?
We can take a look in the Keptn's bridge, what is going on. So we would see that there is a new service sent or a new deployment sent in dev.
Oh, did I send it to the right? Yeah, there's no environment there, so that command is okay, isn't it?
Yeah, that's fine. We can just remove the suppress WebSocket, so we can also see the logging output, because that's actually what we are we don't see right now. But we'll see starting updating the chart cards of the stage dev.
There we go.
And here we go. Has no deployed releases. Okay, it failed in the first time, so the Helm release is actually not working. So now it's basically in an undefined state with Helm. That's the
I've had this so many times with Helm, where the first release fails and then you get stuck in this limbo land where you need to actually remove the old release. So if I mean, will my standard Helm tooling work here? No.
Yeah, it should work actually, because Helm should also point to the same cluster. And
there we go. Okay, so we can do sockshop.
It's sockshop minus def. This is how the
delete and the release name. That's DB.
Oh,
I don't see it. Well, the event probably had it, didn't it? Yeah. Okay. This one. There we go.
Okay.
So we could we should be able to trigger that new artifact again, and it should start from a clean slate. Maybe.
Yeah, but is there any chance that we can bump the size of the cluster a little bit, because it will do the same in staging and in production, but in staging and production we will do a blue-green deployment, so we have two versions of cards running. So we might run out of space also in staging and production, because we are adding 5 more containers to the show.
Yep, no problem. Okay. Go. All right, I've increased that size. There's a new node pool being added now, which should give us 5 more nodes. So let's see where the status of that is. Did I do that right?
And I think that gives me the chance to rethink about our demo application, since it's a little bit too big for very, very small shopping cart, and it takes just too much resources. It's just that we're going for a database plus a small UI and a little bit of it's just a small microservice. Maybe we should go with 2 small microservices that talk to each other and are very, very small, maybe just pinging each other, and then we can also showcase the capabilities.
All right, let's just see how far along that is. It shouldn't take too long. Let's see. One, two, three, four, five, six. That doesn't seem to be adding my new node pool. Okay, I'm just going to increase the size of that. So I may lose the API server for a few minutes, but we can deal with that. The joys of a live stream, right? Okay, let's see.
Exactly. Yeah, maybe we have more questions coming in, then we can also do a couple of questions.
See, happy now? Yeah, okay. That should be spinning up now. So let's see what happens. We'll give that a second. Okay, we do have one question just now we can tackle, and then we'll cover a few other things. So Bala asked, does the user have to manually update Istio to keep up with their releases?
Yes. So Istio is not managed by Keptn. It's just for blue-green deployments right now. It's needed by Keptn, but it's not managed. So you would just install it by yourself and take care of the latest versions of Istio. Maybe in this context, I can add that upgrading Keptn is usually done with the Keptn CLI. So we release a new Keptn version every 4 to 6 weeks, approximately. And there you can, usually it's just a Keptn upgrade, and it will just upgrade your Keptn installation and move all the services to its latest version. If there are new versions of other depending services released, then you would just have to take care of this yourself.
Cool, thank you. All right, can I trigger Keptn send event again, and we should see it work this time? I won't suppress the WebSocket. Let's follow along and see what happens.
Let's try.
So I guess that also explains the weird situation then, because you were expecting this here to see the generated YAML, which I'm assuming isn't there, maybe just because that release wasn't successful the first time. Is that right?
Yes. Yeah, there are a couple of things going on. The Helm chart will be generated and the Helm chart will be applied. And the CLI will wait for the Helm chart applied to, for the Helm upgrade, actually, I think it's a command, to be finished. So in this case, it takes a while, since just the start of the container takes a couple of seconds. So normally it's this command, if you have I have a very small Go application that I'm using sometimes. It's called the Potato Head. It's a CNCF demo project. And with the Potato Head, this command finishes within, let's say, 5 seconds, because it's very small. It's startup. Like the startup is really fast. With the shopping cart, the startup is a little bit longer and slower. So also this command just waits for the first successful deployment in the first stage. So it won't wait until it's deployed into production, but it will just give you the feedback if it could be deployed in the first stage. So it finished upgrading the chart. That should be fine. And yeah, now it's writing the generated ones, and now it's all good.
There we go.
There we go. Finally.
All right. So that what it turns out then is my wild idea about suppressing the WebSocket. We actually managed to time that right. That I did it on a request that failed. So go me. Thanks. All right. Let's go back to our tutorial. So we have done both of those, and we should be able to verify all this now. So let's try that one more time. There we go. That looks much better. So we got
that
the
looks
staging
better,
once
and now
better.
we can also see it's starting up already in staging. There is also a difference when we take a look at the pods and the containers that are running in the pods. For dev, there is only one container running. For staging and production, there will be two containers because we will also have the Istio sidecar. But for dev, we decided not to go for blue-green deployment. So there is no need to inject the Istio sidecar because we don't need this traffic shifting between blue and green versions. And we're only going for this in staging and in production. If we take a look in the Keptn's bridge, there should already be the link to this service available. So we can also take a look at the UI of this very beautiful shopping cart. Actually, yeah, it's dev. Yeah, here we go. And that's our shopping cart. Yeah. So it took it took a while to see this very nice UI.
Cool. So I'm just curious then, if I come in here, take a look at this. Yeah, this won't get the change that I made in dev, right? This is something I would have to manually update here. We'll see if we can get away with it with those extra nodes. Okay. So that's cool. Nice. So we've already looked at that. I'm happy with that. We go to next. So now it wants to generate some traffic.
Yeah.
Do we want to do that, or will
we can also skip this part as we. I think what's really important to where we. Oh, sorry, I think did I just lose you for a second?
Oh no.
Okay. So I think what will be interesting to take a look at is how we can connect Keptn to Prometheus and also run a quality gate evaluation with data from Prometheus. Maybe I think we still have a couple of more minutes left in the stream. Or David, how long is the stream scheduled for? Another couple of minutes?
I mean, it's scheduled for another 15 minutes. If you want to go over that, I'm fine. As long as you've got the time, we can go until we get the Prometheus stuff done.
Yeah, I think if we just execute the installation of Prometheus and do the configuration, should be quite fast, and we will get the data.
Yeah, but now that you've said that, something random is going to happen, right? So we're deploying Prometheus. We are going to configure Keptn. Okay, we're just telling it that Prometheus, Keptn configure monitor Prometheus. So this is a command that you want to tell me what that does?
Yeah, it also says here. So what it does is it will set up Prometheus, and it will also configure Prometheus in a way that it will generate the scrape jobs for carts in dev, staging, production that we can use the data afterwards. And if we would have set up already the SLO files, the quality gate files, that it would already set up the alert manager rules. So right now we have not added the SLO file, so there is no alerting yet, since we have not defined the quality gate yet, but this will be the next part.
Okay, got it. Yeah. So this is using my local shipyard, right, to kind of piece this together. When I run this Keptn configure monitor Prometheus, it's looking in the shipyard file here. Or no, it's sending the event to the control plane.
It's sending the event to the control plane. It's taking a shipyard file from the Git repository.
Got it. Okay, that makes sense. We don't need to browse to Prometheus. So
yeah, we can go for the next. And here, sometimes I need a little bit of explanation because it's the Prometheus service. That's the one responsible for configuring Prometheus. If you don't want to configure Prometheus with Keptn, then you just need the Prometheus SLI service, the service level indicators. In our case, we want to do both. So we have the Prometheus service and the Prometheus SLI service. So this service we also need. It's a service that we also deploy into our Keptn namespace, and it's just responsible for querying Prometheus and delivering the data from Prometheus to Keptn. And with that, we already set up Prometheus and the integration. And now we need the quality gate. And the quality gate is our SLO file. It's written here, and we can just use it as it is. And it will check basically for the let's say, I think it's for the response time. We're just checking for the response time of one service.
Okay, yeah, so it's doing an average across response time, P95. Okay, and it's got some criteria. Excellent.
Exactly.
Okay, so I can do this just from the bridge, right?
Yes, so we can take a look if it's already deployed in staging or in production.
So service environment, staging, carts.
It's here. That looks good. I think in production I have not seen it yet. Its cards is not yet deployed in production.
BB's there.
Not yet there. Maybe we can take a look in the bridge. Normally the bridge gives us, if we go to on the left side, if we go to services, then we can take a look directly on the service on the cards. And if we click on the last configuration changed, we can see the configuration changes is usually the part. Oh, it's trying to already fetch the SLIs. Actually, it's trying to fetch the SLIs, and at the same time, we just deployed Prometheus. So I think there is a kind of a race condition here, because this part would be skipped if Prometheus is not installed. So normally you can do it without monitoring, and then it will just be skipped. This time we deployed Prometheus, but we have not added already the other parts. So what we can do is we can just do another deployment or trigger a new deployment of cards to just rerun the whole thing with the same version, and it will then fetch the data.
Okay, so I just want to make sure I understood that correctly. So our production approval strategy has some sort of performance monitoring before it does an automatic rollout, and it just managed to catch a Prometheus existing in time for it to try and check that the performance was adequate, roughly?
Yes. So it's working in this way that with this command, we are deploying cards in the dev namespace. Then Keptn will trigger the tests. We have added a JMeter file. This will be triggered. Afterwards, there will be an evaluation based on the SLO file. We have not added the SLO file for our dev environment. We only added it for staging. So in dev, it will just skip the quality evaluation. For staging, it will deploy, it will trigger the tests. We have added the load GMX file. So we will add some performance tests or like execute a couple of thousand requests against this shopping cart. And then it will do the evaluation. We have defined the SLO file, and we have defined the Prometheus SLI provider. So this will actually query Prometheus for the data of the testing time, and then come back with the data, provide this to Keptn. Keptn will do the evaluation based on the SLO file, and then come up with the total score. That is actually everything that's going on in the background when you just send this one command. Keptn, and I think at the beginning I mentioned that Keptn acts as this control plane and the orchestrator of these tools. So it connects JMeter, Prometheus. Later on, it can connect Unleash or Ansible Tower to trigger remediation actions. So there's a lot of things that are sent that will receive events or send events. So in this is what we this is what's going on here in the background. Yeah, nice. We can see. In this case, there is not a lot of evaluation because we don't have the SLO file. But if we add an SLO file to our dev environment, then we would see it. Actually, right now it's quite fast. The gatekeeper already decided that since we got the, let's say, if there is no SLO file, Keptn will treat it as let's say a past evaluation. So it moved on, decided to promote it to the next stage. For staging, we have automated deployment activated. So it already started to deploy it in staging, and maybe we already see that tests are executed in staging. But yeah, we just need to wait a couple of seconds or minutes for the test to be finished.
Ah, right. Okay. Gotcha.
Yeah, so we can see it here. Deployment finished, then Keptn was triggering the tests. Keptn was also doing was fetching then the SLIs, evaluating the SLOs, and then deciding if it should promote it or not. So this is how it's going.
All right, nice. I like it. So that's just going to take another minute. Why don't we tackle another quick question? So the question is the Keptn CLI using its own service account and tokens when talking to the control plane? I'm assuming it might be just using my kube context. I'm not sure.
Yeah, we are using our own service account. In the beginning, we were just using the default service account, but this was, I think, changed with 3 versions ago, we changed, and now we're using the Keptn service account. So you have a little bit more flexibility and control what Keptn is actually allowed to do.
All right, nice. Okay, so should I refresh this? It looks like it's rolled out to dev and staging, but I don't think we've had a production deploy yet.
It's still, maybe we can take a look in staging if it's if the deployment has already finished. Then if the deployment is already finished, then we know that the tests are also executed in the background.
We've had a CPU thing again.
Okay.
Okay,
so we're hitting another CPU limit. Yeah, it's just I think the problem that we are.
Sorry, let's just remove it, and then I'll trigger another event, and we'll see if we can get that to run through in time. So we can just say find the CPU. I'll just commit that to prod before doing the new artifact as well. So edit. Yeah, this cluster has a lot of nodes, but it's relatively small hardware. I should have. I normally over provision everything as well, like 1 billion cores, but today I was a bit more sensible. So I'm going to trigger this new event based on those changes inside of the repository. So yeah, let's see what happens. I'm curious. So would you say the bridge is the best way to follow along the progressive rollout of this application? Would you use the CLI? I mean, what's your preference as someone that uses this day in, day out?
I think the bridge gives most details, because if, for example, if we can take a look in, let's say, in the bridge on, let's go for a previous run, maybe there where we can see a little bit more, and let's probably go for some. Okay, maybe we don't see a lot of data. Maybe go for an event of. Yeah. Anyway, go for any event. On the very right-hand side, there is this computer icon or laptop icon, and here it gives you the full cloud event that was sent to Keptn. And if you have a quality evaluation or a SLI retrieval, then these cloud events, they get a lot of information. So usually you have all this information. You have also, if there is an error message, you should be able to see it there if the SLI provider sends it. So since the reason that we are running out of CPU is happening after the Helm upgrade, we don't see this exactly, because that would mean that we send another event after we do the Helm upgrade. But if there, for example, if there are any tests that are failing, or if there are some service level indicators fetching, then we should be able to see this. We should see all this data here. Probably, if we close this window and go to the test finished in our dev, maybe in the previous run at 320, there is a test finished event in the dev stage. So it's a little bit on the top, and maybe we can see here. Yeah, it just says that it's coming from the JMeter service. And yeah, it doesn't bring a lot of information. We just know that the JMeter service sends a pass of the tests. It just executed one test. What we will see is more in staging. We have added more tests, so we should be able to see this in staging.
Okay, so staging rollout is just about completed. It looks like it's just waiting for the Istio sidecar, maybe. Well, you know, one container pending here.
Yeah, well, it should come
a
up.
second. I'm so impatient. I should just run a watch.
That's good. So one is coming up,
awesome.
and the other one is being terminated since we don't need it anymore. That also means that now the tests, we have not made it yet to production because the quality gate in staging never was not successful yet. So in this case, we cannot ship anything to production as long as it's not validated in staging.
Okay.
So what we'll see is the deployment finished. And after the deployment is finished, right now the JMeter tests are being executed. There is one improvement coming in the bridge that we will indicate also that now tests are being executed. It's a little bit missing here, this information, because we just see the deployment is finished, and it needs some background in Keptn that we know, okay, every time the deployment is finished, Keptn will trigger the tests. This information, unfortunately, is missing in the bridge. Yeah, we somehow missed to also put this information in the bridge, but we are working on this to improve it.
Okay, so we just need to wait for those tests. So does that take long?
Usually about 2 minutes. It's a couple of, yeah, and then I will just reach out to move a couple of things.
Oh, have you got another call scheduled now?
Yeah, I think I can move it. So I'm really excited here to get this into production. You know, that's all we want with Keptn, shipping applications to production without breaking anything, and we are good in breaking here. So.
No, this is really good. It's starting to click with me now. I can see, and I'm starting to understand this UI. It kind of threw me at first, but what we can see is this config changed event here, and then we're actually, it just, I don't know how I missed it, but we have the first event here, and then it says, okay, for development environment, we're going to do a deploy, we're going to run our tests. We got their SLI stuff going on here. It does some evaluation, and you can actually see it move on to staging. Like I can actually start to see how all this flows together now. It's starting to make much more sense to me. In fact, there we go. There's our production now. Events kicking off. So I've had the light bulb moment. I now understand what's going on. Which means if I pop over here.
Okay, so we could see, yeah, and the evaluation. What did it say? Did we get a good score in the evaluation? That's pretty good. So we got basically a pass with 90%, which is no, actually with 100%. So what we've done here is, or what Keptn has done is, it was triggering the tests. The tests have been finished. It was reaching out to Prometheus to query the data for the exact testing time frame, and now we can see that the response time is meeting our requirements. So that's pretty cool. And now we're moving on to production, and in production it's doing the same game with deploying. Trying to execute tests. Actually, in production, we have not defined any tests. Usually, it's our end users doing testing, let's call it, for us in production. But yeah, this is what we'll see. And with a blue-green deployment, we have prepared a second version of this microservice, which is a very slow version that will break the quality gate, and that will not be allowed to move on from staging to production. I can already spoil this a little bit because the tests are, I'm spoiling because the tests will be running for a couple of more minutes, since we're sending the same amount of requests. I think it's 5,000 or 10,000 requests against the service, and instead of 2 minutes, they will take about 8 minutes. And I'm not sure if we want to wait these 8 minutes to see this evaluation. It will be red and will be indicating that the response time for the 95th percentile is not within the boundaries that we defined. So this is what we will see.
Okay. So does this change now mean that we have this deployed everywhere? I mean, if I run get pods in production, that's it. Oh no, this is. So what's this primary pod that's running? Is this more tests?
No, that's actually. Since we're doing this blue-green deployment, we are spinning up the first version, and we are spinning up also another version. So we prepare the blue-green, the traffic shift already. This time, it's the first deployment. So we are bringing up 2 times the same version. So we cannot really roll back because there is no previous version. But if we do more of those blue-green deployments, if we send the Keptn, if we send the shopping cart in version 11.3, 11.2.3 that are already prepared, then we can see the primary is the one that's receiving the traffic, and the other one is the one that will go away. So in staging, there is only one left, and in production there are right now 2. But if after some evaluation period, if there is no rollback indicated, then the other one will just be removed from Keptn.
Okay, I understand. Nice. So is that my full rollout of cars finished?
In this case, yeah, we are finished. It would have been possible to just bring carts on the browser and take a look when there is the traffic switch actually from one version to the other. We are doing the blue-green deployments with Istio, so that means we are deploying the new version, and once it's ready, we are moving the traffic to this new version. And if we're going back, then we are first moving the traffic to the previous version and removing this. So there's no downtime or anything. That's actually what we already know from Kubernetes, but it's also in this way we're using. We are basically implementing a little bit by ourselves, but we made sure that there is no downtime when switching from one version to the other.
All right, cool. Is there anything else you'd like to show just now?
Pardon?
Is there anything else you want to go over?
So what we've seen right now is blue-green deployment, the multi-stage deployment with Keptn, with Helm, with using cloud events, with having Istio, with having Prometheus. So I think we have installed a lot and had a lot of technology, although the parts that once set up, it's basically just the Keptn CLI that you need with the Keptn send event, new artifact to trigger a new deployment or configure your monitoring to set this all up. As said, it just takes a while for the second version to run all its tests, but we have also added the Chimida tests. I'm happy to stay and move through all the other parts of the tutorial. But yeah, if you want to wrap up here, that's also totally fine. And maybe we can do a follow-up and taking a look maybe on the auto-remediation parts of Keptn later on, because this is basically, once we have things up and running in production, it's another use case of Keptn to trigger remediation actions and to evaluate these remediation actions.
Okay. Okay. So let's. I have no idea. So let's decide what we want to do. What I want to be careful with is I don't want to rush anything that we show so that people don't get a good understanding of it. But at the same time, I'm happy to make sure that we finish off what we started now. So we can definitely schedule something else and we can cover more of the Keptn features. You're saying if we deploy the slow one, what that's going to do is show us that the tests fail in the staging phase, which will block the deployment to production. So why don't we trigger that now? We'll see if anyone has any questions, and we can do a little bit of a summary while we wait for that to happen. And then we can schedule a follow-up and we can dive even deeper into anything that we haven't covered particularly yet.
Sounds good. Right. Yeah, let's deploy the slow version because it will be quite nice to see what is going to happen. That Keptn will deploy it first, we'll trigger the tests, and then come back with the rollback of this version.
So this would typically happen in my CI system. It's saying, hey, we have a new artifact we've just built, this new release, we've tagged it with 0.11.2, we send the event to Keptn. What's happening here is that because Keptn is an event-driven system, it detects this change. So there we go. We can see here. And that's now going to start to prepare the deployment to our development environment. And I just want to make sure we tie all of this together. If anyone has questions, please drop them in the chat and we'll tackle that. But if we come over to here, let's go back to directories. That's right. There we go. This is like the entry point. This describes all of our environments. The shipyard.yaml, and I just want to make sure we cover this again. So we have our development environment, which has a deployment strategy of direct and a test strategy of functional. So what that means is the deployment strategy will always deploy whenever there's a new artifact, and the testing strategy means it's going to run the functional tests, and if they pass, it won't roll back the deployment. Is my understanding of that correct?
Yes.
Okay. So if my functional tests failed when I built that new artifact, it would revert the deployment back to the last working version. If I get anything wrong, just interject.
In this case, no. So if you do a direct deployment, it won't roll back anything. What it will do is it will block it from move on to the next stages, obviously. So if the functional tests fail, or if some quality gate may be responding on or checking the response time, or the throughput, or the number of outgoing service calls, or whatever, if there is a quality gate that fails, it will block it to move to the next stage. With a direct deployment, it will rollback is only supported in blue-green right now.
All right. Okay. That makes much more sense. Then we have our staging environment, and this time we have an approval strategy of automatic on a pass and automatic on a warning. So regardless, it's going to do its best. As long as the test pass is going to promote that to the next stage. And our testing strategy here is in functional but performance. Now, are these test strategies, is this related to the GMX configurations that we applied earlier?
Yes, it's related also to the JMeter service. So it's basically an indicator which kind of test to execute. The JMeter service, they also have a configuration file, but it's not needed. There is no additional configuration file needed. So we only added the JMX file, which are basically already the test instructions. You can always add a little bit more configuration to configure the number of users and concurrent users and number of requests to be sent. But the test strategy already indicates which test to execute. If it's just a functional test that are usually a little bit faster, or performance tests that hit more load. Yeah.
Okay. So these deployment strategy values, this seem kind of special. So we've got direct, we've got blue-green service. Is there like a canary? Are there any other deployment strategies that we haven't really looked at?
Canary is not yet supported. Everything is prepared in the background. So with Istio, it will be very easy to shift the traffic not only from 100% to 0%, but doing like 100%, then 80-20, 70-30, 50-50, whatever you want to do. It's not yet implemented, but this is something that's also coming in the next stages. It's interesting also that we have not received, or it's not the most common thing or not the most common request that we get, that we have to implement Canary. It's more the multi-cluster support, actually, that we already had in the stream that people were asking.
Yeah, I can imagine why. Okay, and then the last part of our shipyard YAML, we define our production environment, has a slightly different approval strategy of automatic/manual, and then the remediation. So one of the things we did at the start, which was really subtle, but I think is also important, is that I'm not going to. I bet I can't find the command now. But when we onboarded, did we override the deployment strategy on one of these? Yeah, we did here, right?
Yeah.
So for individual services, I can actually say, I I don't want a blue-green deployment of this. Like, I guess the database is a really good example, and probably why it's included in the tutorial. You don't want to run two different versions of them at the same time. You may just want to go ahead and bite the bullet and get that running as fast as possible. So is that reflected in the Git repository somewhere? If I take a look at something?
Mm-hmm.
So if I go to, that file won't exist. Try it again. Go to dev. There we go. And take a look at CarsDB. Is it metadata? No.
It's actually the way we will that Keptn stores it in the Helm chart. So Keptn won't create these virtual services for Istio if we don't need a blue-green deployment. This is how we can see if it's a blue-green deployment or not. There is no, in the metadata file, you won't really see it. We're planning to also include this when you're doing a Keptn get services or Keptn get projects in the CLI, that we're also including everything that's really running in the cluster, that we provide all this information directly with the CLI or with the API. Via the API, you can already query all the events that are stored and running through Keptn and also stored in Keptn. With the CLI, it's we have a couple of convenience functions that you can, like Keptn get projects, and it already lists the projects in a human readable way instead of giving you the whole cloud event with all the projects. So yeah.
Cool. All right. It's getting there. It's all coming together now. Let's see what's going on over here then. So our dev environment, the tests finished. We only ran functional. We didn't run performance, which is why we're getting a green evaluation. This is now being promoted to staging, and it's not ran test yet. So that's running our performance tests now against this red version here.
Exactly. So we know it's already deployed, the red version, and we know that there are the tests running. As said, I would assume this still take a couple of minutes. So normally it's around 5 to 10 minutes, normally like 8 minutes. So in a couple of minutes, we should see if the tests have been finished successfully. So that's also one of the the nice parts of this integration, that the JMeter service is also indicating if the tests have been finished successfully. So it might happen that the tests are breaking and we don't even get a, let's say, a successful test result from JMeter, because maybe the service is not available, maybe the service was crashing. And this is also taken into consideration of Keptn, not only the SLO file. So if the JMeter file or neoload, if the JMeter tests or the neoload tests or whatever test integration you're using, if this is failing, then Keptn will get this information and will also mark the quality gate evaluation as failed, since it could not even execute the tests. If the tests have been executed successfully, then Keptn will go ahead and evaluate the quality gate. And our quality gate is very, very small. We only have the response time in the 95th percentile. You can add more and more SLIs. So we have seen quality gates with like 50 SLIs that are combined together, and the total score is generated. And they range from number of outgoing service calls to memory consumption, CPU saturation, response time, throughput. All these different metrics, they are used. And you just define them once in the SLO file. And in the SLO file that we've seen also earlier, it doesn't say which service it belongs to. So if you have an SLO file that is like your standard configuration of your quality objectives, then you can reuse it for all of your microservices. And reusing is easy in this way, since you can define absolute thresholds, but you can also define relative ones. And I always like to have a combination of both, that I say, okay, it's the error rate has to stay lower than 5%, but it's also not allowed to increase more than 25% to the previous builds. So an increase of the error rate by 25% is like rather frustrating, let's say. So I can combine a relative and an absolute value, same for all the other metrics. And in this way, I think it's very easy to reuse it also for other services, since they don't have actually the name of the microservice or the stage in the SLO file itself. It's just how you add it then to Keptn via the CLI or via the API.
All right, nice. So this test has been running for 7 minutes. So we're expecting this to come back and crash and burn very, very, very soon, right?
Yeah, exactly. The next event should be this SLI retrieval. And SLI retrieval, as we know from Prometheus, it's very fast. Usually you get this data close to real time from Prometheus. So other solutions, they take a little bit more time to digest and to operate on this data. But if we ask Prometheus for data, we get it. We retrieve it pretty fast, and then we should see the SLI retrieval done, and the evaluation of the quality gate pretty soon. And we should also see then the action that is taken by Keptn upon this quality gate evaluation. So if Keptn allows it to promote it to the next stage, or if it will be rolled back to the previous version. And we remember that the previous version was the green version. So we will see what happens.
And can I just, I guess if I pull up the pods in the staging namespace, will that show me the tests?
You won't see the tests here because they are executed by the JMeter service that is running anyway.
Right, okay.
In previous versions of Keptn, we built upon Knative to allow scaling down to 0 for a couple of different services of Keptn, and only react when there is a new event coming in. But actually, Knative was the memory footprint of Knative was already quite demanding. So we decided to remove Knative and just go for Kubernetes and allow all the services to just keep running.
Right. We have our failure.
Yeah. That's actually what we wanted. Yeah, that's good.
Yes, so it says here that our SLI retrieval start date is done. We do our evaluation. We can see that we have quite a large amount of red here, and we can see the result was a fail, which means that this change will not be propagated to production, which is what we want.
Which is pretty cool. Maybe we can take a look if it actually did the rollback. There is the service in the deployment finished event. We should see the blue arrow that we can open up the microservice, and we can take a look, and it's rolled back to green.
Yeah, nice. There we go.
We made it.
Awesome. Very, very cool. I like that. We got there. All right. Nice.
Yeah. We did it. We did it. Awesome.
Yeah, there's this so much going on there, but I think the flexibility and the way that we can encode essentially, which is, SRE playbooks to a certain degree of how we want our applications to handle failures, how we want to be able to test them across environments, and have Keptn orchestrate all of that for us is a really, really cool thing. Call me pretty much impressed with what we've seen here today. And based on what we have in this tutorial, let me pull that back up again. My stupid tab thing. We still got 40 minutes worth of other things we could be looking at as part of the full tour. So maybe if you could just take, a minute, or in fact, maybe we should just reschedule something and not do that. Yeah, let's do that. I think we've covered so much today. Is there any final thoughts you want to leave us with? And we'll come back to this another day.
I think it was a very amazing journey that we did a little bit of debugging already, and we took a look at the DevOps, the GitOps, the GitOps approach of Keptn. I think that was very fascinating to also for me to see this how fast we've done this changes of the small hiccups in the Helm charts. And it was really a pleasure to walk through Keptn here with you, and also seeing this from the other perspective. Normally, I'm sitting on the keyboard doing all this.
Awesome. Well, thank you for. Sorry, Nico.
Sorry, I would be happy to join you again and to take a look at the auto remediation part of Keptn once we have everything up and running, so we can just do one deployment, send it all the way through production, then play a little bit with the auto remediation parts where Keptn is triggering Ansible playbooks or feature flagging frameworks and these kind of things. So to also see once it's in production how Keptn can help.
Yeah, definitely. We'll sort out after this. But I think what we've shown today is just the progressive delivery stuff is really cool. I hope people get an opportunity to play with this, and we'll come back with more episodes and we'll take a look at all those other features as well. So thank you, Jürgen, for joining me today. It was really fun to kind of walk through this and see how it all clicks together and how it works. Really cool software, and thanks for your efforts. Keep it up. We'll speak to you soon.
Thanks, David.
Have a nice day.
Thanks, everyone.